All right, so converting between Fischer projections and perspective formulas is pretty straightforward. It just uses it uses all that you know from R and S, all those concepts. It's not really anything new. It's just a new way to use those concepts. So to start out, we want to going from a Fischer projection. All right, so we want to decide what we want to figure out whether this is RS. So let's assign priority to these groups. So this substituent has an O in it, making it first priority because none of these have anything. The element with the highest atomic number is carbon, which is lower than oxygen, and these substituents, so they're both lower than that. So remember, you count triple bonds as each bond is counted as a single bond. So this carbon is bonded to 3 other carbons, and this carbon is bonded to 2 hydrogens in a carbon. So this is going to be second priority, and this is third priority, and of course the hydrogen is fourth priority. So we're just going to go from 1 to 2 to 3, and that is counterclockwise, making it making it S. However, the hydrogen over here is on the vertical line when it needs to be on the. Sorry, it's on the horizontal. It's on the horizontal bond, and it needs to be on the vertical bond for this process to work properly. So you want to, in order to do that, you want to swap these 2 substituents. Of course, that you're still going to get in the counterclockwise direction, keeping it as an S. However, since you switch 2 groups, that's just going to convert it to the other enantiomer, meaning that because that's what happens every time you switch 2 groups, it goes to the other enantiomer, meaning that you got S. However, it was really an R. R is what that is. So this is an R. Now, for drawing this as a perspective, well, you already know how to draw molecules. You know how to draw perspectives. You know how to calculate R and S. There are only two possible ways that you can draw the perspective, as an R or an S, assuming you get all the right substituents, which isn't that hard. And if you just draw it blindly, you have a 50-50 chance. I used to just try to get it right the first time, but that's harder. I'd say just draw it just draw it giving it no thought, and then you'll have a 50-50 shot of it being right. So and I like to put the hydrogen on the dashed wedge because that makes this whole process much easier. Then you just put in your substituents. So put the OH here, put the methyl here, and then the ethene group over here. All right, so again, this is 1, that's 2, that's 3. So right here, we're gonna go counterclockwise. Now that makes it out to be an S, and it needs to be an R. And since the hydrogen is here, you don't switch anything. So, but all we have to do now is just switch any 2 substituents, and we'll get the right configuration. So let's just we'll just keep the hydrogen there, and instead, we will switch the OH to be here, like so. All right, and now to confirm that what we did work, remember, this is one, I'll just number all of these. 2, okay, 1, 2, 3. All right, so yeah, 1, 2, 1, 2, 3. Now look at this, 1, 2, 3. There we go. Goes in the clockwise direction, making this R, which matches with that. So that's how you go from Fischer to perspective. And going from perspective to Fischer is basically the same. I'll just do an example for you. All right, so you gotta draw a perspective. All right, we'll put H here. Cl methyl group. And then how about an OH? All right. So right now, you should pause the video, try to work this out on your own, convert this to a Fischer projection. This should all be at the. This looks pretty bad, but yeah, just this is perspective formula. Try to convert this to a Fischer on your own, and then let's see how you did. All right, so let's first what we do, we gotta assign priority to this. So that's chlorine has the highest atomic number, so it's going to be priority 1. Oxygen has the second, so number 2. Carbon third, number 3, and then hydrogen is pretty much always 4, unless there's a lone pair, like for nitrogen. But we're only going to be dealing with carbon, so you just put so nitrogen is basically always going to be 4 when you're dealing with carbon. Anyway, so at least in this class. Anyway, so this clearly goes in the counterclockwise direction. However, the H is which makes it an S. However, the H is not on the dashed wedge, and it needs to be on the dashed wedge for this to work. So you gotta switch it, the dashed wedge, which it'll still be going counterclockwise. However, once you do that, you're going from the S to the other enantiomer, which is R. So this whole thing is an R. And now you just got to draw. I use the same strategy. So draw the Fischer projection, and then we're going to make our lives easier. We're just going to put the H on top. So OH, Cl, and CH3. Now, so we got 1, 2, and 3. Now let's check this out. So, oh, and look at that. We got it right first try. Isn't that nice? So this goes clockwise, making this an R. So both of these are R's. So this is the proper answer. You got. So you want to make sure you got that. Now, your answer could look slightly different. Like you say, you switch 2 groups and then switch 2 groups again. You may have it may look different, but it should be the same. You just you got to check, make sure your answer is R, along with this. But yeah, just I think the best if you're good at figuring out R and S, you should be good at this. It's not too much more than that. So good luck studying. Hope you do well on this.